Hello everyone, and welcome to another YouTube video. In this video, I'm going to be going through some popular functions to use when we are dealing with continuous random variables. I want to stress that I'm not going to be explaining any of the probability concepts in this video. I will just be showing you how you can use R as a tool to calculate probabilities, quantiles, etc. That being said, in R, we have the ability to calculate the probability density function. So remember, when we're dealing with continuous random variables, we're looking at a probability density function compared to using a discrete random variable where we have a probability mass function. So we have the ability to calculate the probability density function at a certain value x. We also have the ability to calculate cumulative probabilities. So the probability that our random variable x is less than or equal to some value x. We can also calculate percentiles, or also called quantiles, depending on who you are and which term you want to use. And finally, R has the ability to generate random values from a certain distribution. Now in this video, we're going to cover two continuous random variables, two types of distributions. The normal distribution, also called the Gaussian distribution, as well as the continuous uniform distribution, which we are only going to touch upon at the end of this video. Now, if you watched the discrete random variable video before you watch this one, I apologize for the redundancy. But when it comes to all the different functions that we have, or not all, just the ones that we're going to touch upon in this video, when we're dealing with random variables, they differ in two different ways, in the prefix of the function and in the suffix of the function. So the suffix of the function is what is going to help us distinguish which distribution we are looking at. In this case, we're dealing with the normal distribution, a normal random variable. So the suffix is going to be norm. But the prefix that goes along with this norm, that's going to distinguish between which function we're using. And like I mentioned, there's four. We calculate the PDF at a value x, the cumulative distribution, so find the cumulative probability, calculate the percentiles, and generate random values from the distribution of interest. We're going to start with evaluating the PDF at a value x. And the prefix that goes along with this function is d. So if we are evaluating the PDF of the normal distribution at a value, let's say 3, where the mean is equal to 10 and the standard deviation is equal to 4. So this gives us f at 3. We see the probability down here in the console. It's about 0.02. Now, something that I want to note is that if I just put a number here, or let's change the number. We'll put 0.5. If I just put a number here and I don't specify what the mean is or what the standard deviation is, we can see in this yellow strip what the default mean and standard deviation is. The default mean is 0. The default standard deviation is 1. Those are the values of the parameter that are used when we don't specify other values. And the reason why those are used is because that is the standard normal distribution. So if I run that, just know that this probability, so this value of our PDF at 0.5 corresponds to mean 0, standard deviation 1. Now, moving on to cumulative probabilities. So this is going to be the probability that x is less than or equal to a certain value x. And because we are dealing with a continuous random variable, this is actually just equal to the probability that x is less than x. So the prefix that goes along with this is just going to be the letter P. So if we're looking for this cumulative probability, and remember, if I don't specify anything from mean and standard deviation, I just keep that blank, it's automatically going to use the standard normal. So if we don't specify anything, then the values of the cumulative probabilities are going to match what we would see in a z-score table. So if I run this, the probability that a random variable x is less than or equal to 1 for a standard normal random variable is about 0.84. So what's nice about these functions is that we don't only need to just input one number for a value that we're interested in. We can input a sequence of numbers. So say I want not only the probability that my random variable x is less than or equal to 1, but I also want to know what is the probability that my random variable x is less than or equal to 2, less than or equal to 3, and so on. And I want to output these as a vector. So I want P norm. I want to evaluate P norm on this vector going from 1 to 5, where my mean is 0, my standard deviation is 1. And I see that this first value is going to be the probability that x is less than or equal to 1. This next one is probability that x is less than or equal to 2, less than or equal to 3, less than or equal to 4, less than or equal to 5. Now, third, we have percentiles. And the prefix that goes along with this function is Q, which stands for quantiles. So if you call them quantiles, makes sense. If you call them percentiles, don't mix this up with the cumulative probabilities prefix. Just know percentiles or quantiles go with Q. Now to do this, we have Q norm. We put whatever quantile we're interested in. Say we're interested in the 90th quantile or percentile, and I'm going to mix it up a bit. So I'm not going to use the standard normal. I'm going to say my mean is 3 and my standard deviation is 1. And I get the 90th percentile down there in the console. And again, I don't only need to include one percentile. Say I'm interested in the 25th percentile and the 60th percentile. Mean is equal to 3, standard deviation is equal to 1. Oh, what did I do? Oh, because I called that Q, but the argument is called P. So remember, if you ever get an error and you don't know what's going on, or you don't even know how to use a function, we can just put in a question mark, put the name of our function, and run that. And we get all of the information in the help tab of our studio. What's nice about these group of 4 functions, so the D, P, Q, and R, is that if you just search up one of them with its corresponding distribution, you get information on all 4 of the functions. So before I made a mistake, I put Q as the argument in Q norm when it should have been P. It was an easy fix, but if you're ever going crazy, you're like, what is going on? It's easy to just look for help, question mark your function, and then you can read up on the distribution in the help tab. Now, the last function is we're going to be generating random values from the normal distribution. And to do this, the prefix is R for random. Now, we're going to have our norm as our function, and we can even see that in the help tab over here. And the first argument is going to be how many random values do we wish to generate. So if we have n equals 10, we want to generate 10 of them. And fine, we'll generate them from the standard normal distribution. So I won't specify any values for mean or the standard deviation. The default values will just be standard normal. At the bottom, we can see that 10 random normal variables have been generated. Now, if we want to check if these look like a normal distribution, we can plot a histogram. And if you're like, what the heck is that? You didn't teach us how to do that. Then I suggest that you go back to the Art and RStudio basics videos where we talk about numerical and graphical summaries. I do show histograms there. So I'm generating 10 random values from a normal distribution, and I'm plotting a histogram of them. So that doesn't really look like a normal distribution, but we have a relatively small sample size. So if I increase the sample size, so if I take 100 instead of 10, we can see that we do have a bell shape, but we're missing some of that symmetry. So we have kind of a long tail on the right side. So let's see what happens if I generate, I don't even know how many zeros I put there, a lot of values from a normal distribution. We see that as we increase the sample size, the distribution of the values, the random values that we are generating, look more and more like the distribution that we are generating them from. So yes, if we only sample 10, when we plot a histogram of them, they may not look like a normal distribution, but they are still sampled from that normal distribution. We just need to increase that sample size to see it visually. So those are the four functions. We have calculating PDFs at a specific value, calculating cumulative probabilities, finding or calculating percentiles or quantiles, whatever you want to call them, and generating random values from a given distribution. We have covered all of these under a normal distribution. When it comes to other distributions, such as the continuous uniform distribution, the format is the exact same. The prefixes are still going to be D, P, Q, and R to do those four different functions. But what is going to differ is the suffix that we're using. With the normal distribution, we use norm. With the uniform distribution, the suffix is going to be unif. And because we are dealing with a different distribution, the arguments inside each function are going to differ as well because the distribution calls for different parameters. In the normal distribution, the parameters are mean and standard deviation. With the uniform, we have that interval because we are defining a distribution, this uniform distribution on a random variable in a given interval going from A to B. And you'll see, so if we use dunif to find the value of the PDF at a given X, the interval A and B is called min and max. So min would be A, max would be B, and X is just going to be whatever we want our PDF to be evaluated at. So if we want, what is the PDF at 2 when my min is equal to 0 and my max is equal to 7? So the probability of that is about 0.14. With the cumulative probability, again, we can do the exact same thing. But here, what we're going to get is the probability that X is less than or equal to whatever we set our first parameter, in this case, the 4, to be. So if we do that, we get about 0.57. Again, these all have the exact same format as the normal distribution. That's why I'm kind of rushing through these a bit. So when we want to find the quantile, we use the Q prefix with the suffix of whatever distribution we're looking at. Here we're looking at the uniform distribution. And with each function, we need to include what the parameters of that distribution are going to be. Finally, we can generate random values from a uniform distribution. So here I'm saying I want 10 random values from a distribution, a uniform distribution, where we are defining this on an interval going from 0 to 7. And I get my 10 values here. So that is everything I have. If you haven't already, watch the discrete random variables, where, again, a lot of it is very similar to this. When we are dealing with discrete random variables, the prefixes are going to be the same, but the suffix will differ. So instead of unif or norm, like we did here, we're looking at the Poisson and binomial in that video. So we use Poisse and binome. Thank you for watching.